Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as normal distribution. Please take down a sum guys. All of you please take down a sum. A customer accounts, the customer's account of a certain departmental store, has an average balance of rupees 120 and a standard deviation of 40 Find first part of the question. What proportion of account has balance over 150? What proportion of account has balance over rupees 150? Second part of the question. What proportion of the account has balance between 60 and 90? What proportion of the account has balance between 60 and 90? Right, let's read the sum guys. They've given you that has a average balance is given to you as 120, standard deviation is given to you as 40, right? Now, let's see the first part of the question. What proportion of the account has balance over 150? Whatever they ask you to find out, you assume that as x1, right? Z is equal to x1 minus x upon t, right? So in that case, this will be x is x bar. So this is going to be 150 minus 120 upon 40. So this is going to be nothing but 30 upon 40, that is 3 upon 4, which is 0.75. Once you have done this, they will give you in the sum that the data is normally distributed. A normally distributed data, that means they have given you data of 120 customers and it is normally distributed. It will be given in the sum. I must have not dictated it, right?
Standard deviation.
Well, yeah, this is standard deviation.
Instead
Z.
of T, that's standard deviation.
Standard deviation. Okay. Now they will give you that the data is standard. The data is normally distributed. Now, when the data is normally distributed, you have to draw a diagram which is called as the bell curve. In the bell curve, the center line shows the mean. Right? So your mean is 120. The center line, when it is normally distributed, this is my actual data. This is what happens to the data when it is normally distributed. The center line shows z is equal to 0. Okay. The bell curve looks something like this. Okay. Now, I want to know the number of people who have scored or who have balance over 150. This is 120. 150 will be ahead of this. This is going to be x1, which is 150. Since it is ahead in the normal graph, it has to be ahead in the distributed graph also, normally distributed graph. So this is going to be z is equal to 0.75. I want to know the people who have scored more than 150, or I want to know the people who have a balance in their account more than 150. Same shading you have to do in both the diagrams. Now, area between t is equal to 0. You have a normal distribution table. From there you will come to know the area. Area between t is equal to 0 and t is equal to 0.75. T or z is equal to 0 and z is equal to 0.75. Guys, someone please tell me how much is that area?
0.3023.
0.3023.
That is for 75.
Yeah, 0.75 area is 0.3023. Fine, do we get this thing clear? Now, you should know that the bell curve is symmetrical. The total area of the bell curve is 1. So each half will be 0.5. Therefore, I can say that area of shaded portion will be 0.5 minus 0.3023. Each half of the bell curve is 0.5. This whole half, that means the area of this region from here to here, whole thing is 0.5. The area of the unshaded portion is 0.3023. Hence, the area of the shaded portion, someone please give me guys.
0.1977.
0.1977. Right, do we get this thing clear? Now, let me have a look at areas 0.75.
3023.
Now, let's see this. Once you have this, they've asked you what is the proportion. Proportion of people having balance greater than 150 rupees is going to be whatever is the area you got, multiply that by 100. If you have to get the proportion, multiply the area by 100. So that is area into 100. That is 0.1977 into 100. That means 19.77% people have got balance of greater than 150 rupees. Second part of the question. They said, what is the proportion of the people having balance between 60 and 90? Between 60 and 90. So I can say that x1 is 60 and x2 is 90. For which I can find out z1 to be x minus x bar upon standard deviation. That is 60 minus x bar. X bar we know is 120 divided by standard deviation. That is 40 minus 60 upon 40 minus 3 upon minus 1.5. Similarly here I can find out z2 is x. This was x1, x2 minus x bar upon standard deviation. So that's 90 minus 120 upon 40. 90 minus 120 minus 30 upon 40. That's minus 0.75. Right? Now I need to draw a bell curve for this. Let's see how does the bell curve for this look like. First I'll draw the bell curve for the original data, and then I'll draw the bell curve for the normally distributed data. Right? For the original data, mean is going to be in the center. Mean is 120. Right? I want between 60 and 90. Right? This is going to be my x is equal to 90 and this is going to be my x is equal to 60. I want to know how many people, what is the percentage of people that have balance between 60 and 90. This is for my actual data. For my normally distributed data, the mean line is called as z is equal to 0. Right? We have found this out. This is going to be, we don't write the minus sign. The minus sign only indicates that it is going to be to the left side of t. Mean line, that is t z is equal to 1.5, negative 1.5, and this is negative 0.75. I want to find out this area. Right? Do we get this thing there? Now, in the sum, they will give you area between z is equal to 0 and z is equal to 1.5 and area between z is equal to 0 and z is equal to 0.75. This data either will be given to you in the sum or they will give you the table. If they give it to you in the sum or table, either way it is going to be the same. The area between z is equal to 0 and z is equal to 1.5 is 0.4332. 0.4332, and the area between z is equal to 0 and z is equal to 0.75 is 0.2734. This data is given to you in the sum. So we will use the data that is given to us in the sum. Okay. Now, area between z is equal to 0 and z is equal to 1.5. That means, I'll use another marker. That means this whole area, guys, from here to here, this area is given to you as 0.4. This area is given to you as 0.4332. Right? Next, this area, that is from here to here. Area between z is equal to 0 and z is equal to 0.75. This area is given to you as 0.2734. Right? In that case, what will be the area of the shaded portion? Area of shaded portion is going to be nothing but 0.4332 minus 0.2734. Someone please subtract it. Excuse me, that is 0.1598. I just told you that when you want percentage, you have to multiply by 100. So what is the proportion? Proportion is going to be nothing but area into 100. So that's 0.1598 into 100. That means 15.98% of the people have balance between 60 and 90. Right? Do we get this thing clear? Okay. Let's see another sum, guys. Please take down another sum. Right. The income distribution of a group of 1,000 people let's continue please. The income distribution of a group of 1,000 people was found to be normal. The income distribution of 1,000 people was found to be normal, and the mean is 750 and standard deviation is 50. Mean is 750 and standard deviation is 50. What percentage of people had income? What percentage of people had income? First part of the question, exceeding 660 rupees. Exceeding 660 rupees. Second part of the question, exceeding 832 rupees. Second part of the question, exceeding 832 rupees. Let's see this. Mean. They give you that the income distribution of 1,000 people, n, number of people is 1,000. They give you that with mean of 750. Mean is found to be 750. Standard deviation is found to be 50. Right? Now the first part of the question, how many people have what is the percentage of this group that has income exceeding 660? So I'll say x1 is 660. And do we get this thing clear? x1 is equal to 660. This is given to you. Now I can find out z is equal to x1 minus x bar upon standard deviation, that is 660 minus 750 upon 50. So that is going to be nothing but minus 90 upon 50, that is negative 1.8. Right? Now area between t is equal to 0 and t is equal to 1.8. Either you will be required to find this from the table, or it will be given to you. The area will be given to you as 0.4641. 0.4641. This data will be given to you either in the sum they will give you the data or they will give you the table from where you have to find this. Now let's try to draw the bell curve, guys. This is the bell curve for the normal data, actual data, and this is for the normally distributed data. Mean is given to me as 750. Now they've asked me to find out the number of people that have income greater than 660. 660 is going to be somewhere here. It has to be before 750. X1 is equal to 660. I want to find out all those people that have income more than 660. I want this whole region. More than 660, exceeding 660. For the normally distributed data, T is equal to 0. And here, T is equal to 1.8. Right? Whatever is the shaded region for actual data, the same will be the shaded region for normally distributed data. So this is going to be my shaded region. I already explained to you that the bell curve is symmetrically divided and the area of each half is 0.5. That means the area of this half from here to here, this whole area of the bell curve is going to be 0.5. And they have given you that the area between T is equal to 0 and T is equal to 1.8, this area is given to you as 0.4641, right? Therefore, I can say what will the total area be? The total area will be 0.4641 plus 0.5, that is 0.9641. They have asked me what percentage of people have income exceeding 660. When they tell you percentage or proportion, it's the same thing. Of people having income more than 660 is going to be nothing but area into 100. So that is going to be 0.9641 into 100. That means 96.41% of the people, 96.41% of the people have income greater than 660. Fine, do we get this in clear? Next, let's see the next part of this question. Second part of the question. How many of them have exceeding 832? Should be very simple, guys. X1 is 832. Z is equal to x minus x bar upon standard deviation, that is 832 minus x bar. Mean is given to you as 750 upon standard deviation. Standard deviation is given to you as 50. This is going to be 82 upon 50, which is nothing but 1.64. Fine, do we get this in clear? Positive 1.64. Now, the data, again, either they will give you the table, normal distribution table, or they will give you the data in the sum. Area between Z is equal to 0 and Z is equal to 1.64 is given to you as 4495. 0.4495. Right? Now, let's draw the bell curve. One for the actual data. This is your bell curve for the actual data. This is your bell curve for normally distributed data. Okay? This is your mean. Mean is going to be 750. I want to know how many people have income exceeding 832. Exceeding 832. This is x is equal to 832. Exceeding 832, that means I want this region, right? For normally distributed data, the mean line is called as Z is equal to 0, right? This is going to be Z is equal to 1.64, right? We found out the value of Z as 1.64 people. Now, they have given you that the area between Z is equal to 0 and Z is equal to 1.64, this area is given to you as 0.4495. But I am not actually interested in this area. From my actual data, I know I want this area. We know that the bell curve is symmetrically divided. Area of each half of the bell curve is 0.5. Therefore, I can say that area of the shaded portion area of shaded portion is going to be nothing but 0.5 minus 0.4495. Someone please subtract this and give me 0.0505. They've asked me what proportion or what percentage. I told you when they tell you proportion or percentage, multiply by 100. So you will come to know this. So proportion is given by the formula area into 100, that is 0.0505 into 100, which is nothing but 5.05%. So 5.05% of the people have a balance exceeding 832. Fine, do we get this in here? In this same sum, had they asked you how many people have balance, then the formula would have been area into N. If they ask you proportion, you multiply by 100. If they ask you the number of people, you multiply by N. Right? Can you please take out the next sum? Can you please take out the next sum? The life of a bulb has a mean of 2500 hours. The life of a bulb has a mean of 2500 hours and a standard deviation of 200 hours. The life of a bulb has a mean of 2500 hours and a standard deviation of 200 hours. Find the probability that the life of the bulb may be. Find the probability that the life of the bulb may be. First part of the question, less than 2400 hours. Less than 2400 hours. Second part of the question, more than 2450 hours. More than 2450 hours. Right? Let's see this. The data given to me. The life of the bulb has a mean. This is with some of you doing third sum. Right? Mean is given to you as 2500 hours. Right? And standard deviation is given to you as 200. Right? First part of the question. How many bulbs have life less than 2400 hours? X1 is 2400 hours. Another thing that I want to explain to you guys, this variable, the normal distribution variable, some authors write it as T, some authors write it as Z. Either way, it does not make a difference. You can write it as T or you can write it as Z. Both the ways, any variable you select is going to be the same. Okay. So I can say Z is equal to x1 minus x bar upon standard deviation, that is 2400 minus x bar, that's 2500 upon standard deviation, that is 200, negative 100 upon 200, that's negative 0.5. Right? The sum tells you that area between T is equal to 0 or Z is equal to 0 and Z is equal to 0.5. That area is given to you as 0.1915. Right? Do we get this in? Now, let's draw our bell curves. This is going to be my bell curve for the actual data. This is going to be the bell curve for the normally distributed data. Ideally, they should be symmetrical. Bell curve. Okay. This is mean, which is given to me as 2500. I want to know the number of people I want to know the number of bulbs that have a life of less than 2400. X is 2400. I want less than 2400. That means I want this region less than 2400. For the normally distributed data, the mean line is called as Z is equal to 0. This is T is equal to 0. Z is equal to 0.5. I want the same region here. Now, I have already explained this to you that the bell curve is symmetrically divided. the area of each half is 0.5. That means, guys, the area from here to here, this whole area is 0.5. Right? And they have given you that area between t is equal to 0 and t is equal to 0.5. That means this area is given to you as 0.1915. In that case, what will be the area of the shaded portion? Area of shaded portion is going to be nothing but 0.5 minus 0.1915. Can someone please subtract this and tell me how much is it? 0.3085. Okay. Once I have this, they ask you find the number of find the probability. So you have to find out the number of bulbs. I was just explaining this to you in the last sum, guys. So I can say that number of bulbs having life less than 2400 hours will be nothing but area into n. Okay, have they given you n? No, they haven't given you n. Life of a bulb 200. Okay. Okay, so in that case, you cannot find out the number of bulbs, you will have to find out in terms of percentage only. So that means this is going to be 0.3085 into 100. That means 30% of the bulbs have a life of less than 2400 hours. How do we get this? Next, let's see the next part of this question, guys. Second part of the question, have life more than 2450 hours. That means here x1 is given to you as 2450 hours, right? I can say z is equal to x minus x bar upon standard deviation. So this is going to be 2450 minus mean is 2500 divided by standard deviation, that is going to be 200. Negative 50 upon 200. How much is that?
0.25.
0.25, negative 0.25. Right? Let's draw the bell curve now. Bell curve for the actual data, bell curve for the normally distributed data. You have to draw both the bell curves. This is mean, which is given to me as 2500. I want more than 2450. 2450 is going to be to the left. X is 2450. I want more than 2450. I want to know what proportion of bulbs have a life of more than 2450. In the normally distributed data, the mean line is z is equal to 0 and this line is z is equal to 0.25. I want this area, right? In the sum, they give you that area between t is equal to 0 and t is equal to 0.25 is given to you as 0.0987. 0.0987. Fine, do we get this? Now, I have explained to you that the bell curve is symmetrically divided. The area of each half is 0.5. That means this area is going to be 0.5 and this area is given to you as 0.0987, right? Therefore, I can say that the area of the shaded portion, is going to be nothing but 0.5 plus 0.0987, which is nothing but 0.5987, right? Once you have this, then I can have proportion of bulbs having life more than 2450 hours is going to be 0.5987 into 100, that is 59.87. So 59.87% of the bulbs have a life of more than 2450 hours. Take on the next one, please. the IQ score of 1500 applicants, the IQ score of 1500 applicants is normally distributed with a mean of 125 with a mean of 125 and standard deviation of 10. What are the limits of IQ? What are the limits of IQ for middle 50% applicants? What are the limits of IQ for middle 50% of applicants? This kind of sum is a favorite with Mithibai and NM professors. Except Mithibai and NM, I don't think anybody else asks these kind of questions. Middle 50%. Guys, that means first let's try to understand the logic behind this sum. If I have a line, I want middle 50%, that means I don't need the first 25%, I don't need the last 25%. That means I need the data that eliminates the first 25% and last 25%. The data that does it, statistically we call that data as quartile. I need the first quartile and the third quartile. So now we are going to apply quartiles to normal distribution. When they say middle 50%, then you have to apply quartiles. Now let's see what is the data given to me. Mean is given to me as 125. Standard deviation is given to me as 10. And number of applicants are given to you as 1500. Right? Now you will have to learn this formula. Guys, for middle 50% I need to find out Q1. Q1 is given by the formula mean minus 0.6745 into standard deviation. Luckily you don't have the derivation of this formula. You have to only remember the formula that mean is nothing but Q1 is nothing but mean minus 0.6745 into standard deviation. Mean is given to you as 125 minus 0.6745 into standard deviation, that is 10. So this is 125 minus 6.745. How did I get 6.745? That's 0.6745 into 10. Someone please subtract and give me the answer.
118.255.
118.255. Right? So this is 118.255. Next, that's Q1. Q3. Q3 is going to be given by the formula mean plus 0.6745 into standard deviation. So that's going to be 125 plus 6.745. That is going to be 131.745. Right? So they've asked you that what is the IQ of the middle 50% of the applicants? The IQ of the middle 50% of the applicants is between 118.255 to 131.745. Fine, do we get this thing clear? I think I've covered all the different kinds of sums that you have in this. Right? We will stop here for the day. Thank you very much.